So, welcome back to everyone once more. I'm David Cooper, this is Arlen Brower, and we thought we'd talk about software testing and being a computational programming software engineering topic, as well as probably something people should be doing as part of whatever else they're doing in computing and software engineering. And Arlen reminded me of the existence of the pragmatic programmer, so hopefully you can see that. And this book has a particular quote in it, which I'm going to partially read out, which we picked out to start this with. The author quotes, the author says, I decided to stop writing tests for a couple of months and see what it did to my code. To my surprise, the answer was not a lot. So I spent some time working out why. I believe the answer is, for me, most of the benefit of testing comes from thinking about tests and their impact on the code. And after doing it for so long, I could do that without thinking about actually writing tests. I could do that thinking without actually writing tests. My code was still testable, it wasn't tested. Andy says I shouldn't include this sidebar. He worries it will tempt inexperienced developers not to test. Here's my compromise. Should you write tests? Yes. But after you've been doing it for 30 years, feel free to experiment a little to see where the benefit lies for you. So that's quite an interesting take. And I guess it goes to the mindset that testing is supposed to instill, I guess the mindset that you need for testing and the mindset that we want testing to give you. So what are your thoughts on what that mindset is?
So I think it's one of those old idioms, right? That like in order to really understand code, you have to test it. Or if you don't understand the code, you can't test it. You know, anything around those sorts of lines. And I think that goes very much to the understanding of, like, if you are actually going to use and test and, you know, make sure that the code works, you have to understand what it's supposed to be doing. So I feel like intrinsically testing is always such a big part of the development process.
It definitely is. And the attitude I think that novice coders have when they come in to coding is that they want to create something based on all the constructs they've been told about, putting all these things together. But the idea that we then need to do this second part and test it, it doesn't seem intuitive somehow. There's an attitude where either it works, in which case I'm done thinking about it, or it doesn't work, in which case absolute panic time and I have no idea what to do. And they only know whether or not it works based on running it once. So somehow we've got to expose them to the need for testing, I guess. Maybe it's a good opportunity to inject this idea that one of our other mutual colleagues came across called learning through failure, where I think this is intrinsic to a lot of disciplines, but particularly programming, where you just have to expect that 99% of what's going on in your work routine, your workflow, is you're failing to do something because you've written some code and it's not compiling, or it's not running, or it's failing its tests. Maybe the tests are there once you've appreciated the need to fail in order to then succeed.
Yeah, and I think it's a great way to learn, especially for coding, because you're not really going to break anything by trying something different in most circumstances. If you're building for an airplane, maybe don't try to break things.
Not on the real plane anyway.
But in general, like, I think that's one of the biggest ways to learn something is you see something, you don't understand it, play around with it, maybe break it, maybe see what happens if you try this, and if you break something, that's good knowledge learned. And I think testing is it kind of falls out of that in a way, because you're ultimately when you're testing, you're trying to think, how do I break this thing?
Exactly, and it's a mindset that you have to learn, I guess, because you're trying to build something, but in order to try to build something, you've also got to break it, which is kind of an interesting dual mode of thought. What's the quintessential thing students need to know about testing? Do you think?
That you have to do it.
Fair enough.
I think that's the quintessential thing.
Yeah.
So many of our industry partners are always telling us that what they really want are students that know how to test.
Yes.
And so if that's the quintessential thing, they have to do it. Here's a question for you. Can you over-test something?
I'm sure it is possible. I mean, you could just keep writing endless quantities of unit tests without end, and at some point, if you've written 10 times as much unit test code as you've got production code, probably a little bit too much. It's an interesting question though, because probably there's no amount of testing that will necessarily fail to detect more bugs. So you could be approaching a higher level of quality no matter how much testing you do, but it is a question about is that incremental level of additional quality worth the amount of time you put into it?
Exactly. I think there's some diminishing returns there. And I even have kind of an anecdote of a friend who he was working on some stuff and he was creating some tests, and I had a look at the test and he showed me what was going on. I'm like, I feel like this might be a little bit overkill, because he effectively had several for loops that were going through every range of possible inputs that could possibly exist for this thing.
Wow. Okay.
And considering that there were numerical inputs in that, it was a little bit overkill for sure.
Yeah.
And I asked, why are you doing that? And he said, well, the project manager said that I need to, because he wants to be absolutely 100% sure that everything works. And it's like, okay, well,
you have to be careful around precisely minded people with terms like 100%. Because if we're going to test all possible values of a 64-bit integer, then good luck.
Yep. Luckily, it wasn't quite that bad, but still very interesting that there were, effectively millions of test cases being kind of like just generated and run. So obviously, it took quite a while to actually do all the testing.
Yeah. There is a form of testing which I sadly forget the name of. I should have looked this up beforehand. Related to fuzzing, I think. Although fuzzing itself is quite an interesting topic, but it's where you have the test code auto-generate its own test data.
Right, yeah.
Just randomly, I guess, within certain bounds and with certain constraints. So that I guess, in that sense, you can just leave it to run
effectively,
however long you like.
Just kind of do some spot checks in a sense. Like, the more times you run that, the more sure you are of the code.
Yeah. So, automate parts of the testing itself.
What about testing techniques? Like, when you're asking what is the quintessential thing student need to know, what about the actual techniques? What do students need to know from that point of view?
That's a really good question, because when I started learning about testing, because I had to teach it, I should know about these things. There was a tension between the idea of building up tests so that you, on the one hand, you test a little thing and then you test something else that depends on the little thing, and then you test something else that depends on those two, and gradually you work your way up to the whole system, I guess.
Right, so kind of like the bottom up sort of.
Yeah, versus using mocking, where you try and take all the other bits out of the equation and just mock all of the components that your little thing under test depends on, which is more complicated, but might in some cases give you a more fine-grained understanding, I guess, of the test results. So do we need students to understand mocking? I mean, probably it's good if they understand testing at any level, I guess.
That's true.
I feel like maybe the one quintessential thing is beyond the fact that they need to remember to test at all. They should understand that they should test automatically, or they should understand that they should automate the testing.
And that's, I think, a big part of industry as well. And we don't talk so much about things like continuous integration, continuous deployment sort of stuff in the degree. But when they get out there, that's effectively what they're going to be doing.
Very much, yeah. It's hard to do that, I think, without them having a project to do it on.
The first time they really get into that is in their capstone.
Yeah. It's one of these things, along with agile methods, that we like to teach, and whenever there's a meeting about what should we teach them, agile, we'll teach agile. But yes, it's along with testing. You can't really do it just in little bits. You have to have the experience of a process of doing it over time, which implies some kind of project, I guess. But
Yeah,
I think we can revamp the whole degree based on what we're talking about here.
Just have the degree be one huge project.
Yeah. It's not necessarily the worst idea in the world, actually.
It gives a lot of continuity.
Yeah. That would be fascinating to think about how that would work, actually. Try and add in all the ingredients or all the units that we want to get across, but with a single context in a way.
Yeah, but it is tricky to do even stuff for just our units.
Yeah.
For example, you've got code in your units that you go through. Do they have test suites?
So most of them, well, actually, one of them does, but most of them don't. Yes,
Yeah.
Admittedly, the one that does is the example on state transformations, and it's actually probably more than one, but not many. The one on state transformations, I put in there so that the students, when they're trying to play around with state design, have something to fall back on when they inevitably fail. Otherwise, I guess they don't know whether they've done it properly at all. Because it's an inherently tricky thing to manually test.
Yeah, and I think that's one of the fascinating things I've seen from websites like Exorcism. If you've come across that one, effectively a bunch of different languages you can choose, and it has challenges. Some are more lesson based, some are more challenge based.
Yeah.
But at the end of it, you have to have some working code, and it has test suites that actually check. Is this basically working? It's not exhaustive. There's some weird edge cases you could probably come up with to break it in some cases. But it's a great way of actually reinforcing learning, I think, is to say, here's some code, does it work? And it goes beyond that idea of compiles, good, maybe play around with it, good. No, it actually has automation built into it from that fundamental level, which I think would be fantastic, but that's kind of hard for us to set up.
Yes. It's not too well. I don't know how. I've never seen it. I haven't, so I don't know how it works. So it's difficult for me to comment on that. But with the code snippets that I give to students in object-oriented software engineering and software architecture, it's because I'm using a build tool, Gradle. Introducing test cases is actually pretty straightforward. It's I've even kind of given them like a base I think I could call it base Java project and base Python project and things. And it's got like a Hello World test example there. And everyone asks me, what's this for? Do I need it? And I have to say, not really, because I'm not actually teaching you testing. At least you can see how it looks. It's gone empty now.
Now that's interesting, though, that, because we're in a situation where, like, okay, the point of this unit is these learning outcomes, and not necessarily testing, but if you're developing code, you probably want to be testing, because one way or the other, your code is going to be tested.
Yeah.
Either by you or by the person marking.
Yes, whatever the unit learning outcomes are, it's inevitable that you're going to touch on the need, at least informally, to test your code. It's it's inescapable, really.
No.
And it's nice, I think, to have a unit designed so that it has at least a tiny little bit of overlap with the units around it, so that you can help students join the dots between all the things that they...
Makes sense.
Yeah. Whether they... I don't know. It's hard to know whether they take that on board or not, but it's there anyway. So, and I'll move on to my second question.
Yep.
So, what do you think is harder for students to understand? Is it the intuitive importance of testing, or the test coding, or the test design?
So that's kind of tricky. I think the first thing that they struggle with is that intuition. And I've even had students, as I'm showing them how to do testing, that tell me they don't see the point of it.
Yeah.
Or, why bother going through all this effort? And the answer is basically we want to make sure it works. But they don't quite get that intuition that, okay, well, just because it compiles and you run it a few times doesn't mean that it works for all different things. And I think that's actually one of those mindset goals that we try to work on throughout our teaching, right? Is that we want people to understand that, especially as your projects get more complex, so does your testing.
Very much.
You make a small change here, you think, oh, that's not going to change anything. You don't know.
Yeah, I've had students completely break their assignment code at the last minute because they deleted a comment, except they also deleted a brace.
Exactly.
And of course they didn't think they needed to retest their code.
Exactly. So I think that intuition is probably one of the most important and longest running things that we do. I think the technical side of things, the actual mechanical, this is how you do a unit test, this is how you mock something, this is how you get automation going, this is how you hook up an automated suite to your GitHub repo, whatever it might be. Those are all very technical, I think, step-by-step things that you could very formulaically go through.
Yeah.
But I think that intuition is a big part of it. And that also kind of ties in with the actual design. Because you probably don't really know how to test unless you know how to break something. Yeah. And you don't know how to break something until you've tested.
A bit of a chicken and egg problem. Yeah. It's interesting trying to figure out how you would give a novice student the opportunity to viscerally understand the importance of testing. I'm not sure how you would do that, but you could imagine maybe have two different systems. You have to do something in system A and you have to do something in system B. One has unit tests and the other one doesn't.
It's a bit of a paradox, though, isn't it? Because we've all come across buggy code or a website with a broken link or anything like that. I think pretty much everybody has encountered that some way, somehow, because we are surrounded by software. So on some level, I think people should understand that, but it typically isn't the case.
It's so big, though, isn't it, compared to what a novice programmer is doing? It's like a website that seems glitchy. It's somehow maybe it's hard to connect that to the idea of the kind of software defect that they would produce in their little command line Java application.
True. Yeah, that's very true.
But yeah, it should be easy to make the case because there's lots of glitchy code out there, and it annoys the hell out of everyone, or it should do. A lot of it is as it is at our university. I've noticed as well.
You can go to our website and there's a link that says something like contacts, brackets, old. So, okay. I'm not sure that's supposed to be there.
Yes. I guess I like maybe my trouble as an educator of people in things related to testing, not testing itself, is I like telling people about the technical aspects of things, and so that's probably the natural way that I would gravitate towards handling a testing unit. Whereas, what I should be doing is figuring out how I can make students want to test. That maybe that's the primary thing that we should be figuring out.
Yeah, I think it's a hard problem though, and I mean it kind of goes to again what our industry partners want, which is people who know how to test.
Yeah, well, I feel like people who know to test, and then obviously they want certain skills on top of that. Yeah, definitely. The testing frameworks for different languages seem quite similar to each other, I guess, for the most part. So they're unlike a lot of the other things in software design, that aspect of it shouldn't have too much of a problem with, the classic, the Android API has changed, 16 times in the past 5 minutes. But testing frameworks don't change that much, so we shouldn't run into that kind of a problem.
And even then, it's similar in a lot of ways, I think, to things like GUI frameworks. If you know how a one GUI framework works, you kind of know how the other one works.
This is true.
The specifics and the quality of life might be different, but the general framework around it tend to be fairly similar. And I think it's very similar with testing as well.
That bodes well for, I guess, what you call transferable skills. So
exactly.
It doesn't matter hugely which particular framework you've formally learnt. As long as you can pick up other ones. How long have we been going for? I can't even remember.
That's a good question. How long have we been going for? Feels like a good amount of time.
Yeah. We can leave it there then, I guess.
Sounds good.
Yeah, thank you once again.
My pleasure.